All right, moving on to section 4.2, graphing polynomials and end behavior. So we want to be able to define a few characteristics of polynomials, define and set rules for end behavior, and graph polynomial functions. So just a really quick review, classifying polynomials by degree. So if we have degree 0, we call that a constant. An example would be 6. Degree 1 is linear. That would be something to the first degree, so something like 4x minus 11. Degree of 2 would be a quadratic. So something like x squared. Or you can get a little crazier and go x squared minus 2x plus 3. 3 we call a cubic, so we'll go like 11x to the third plus 6x squared minus x plus 10. I don't know, something like that. My highest exponent is 3. Fourth would be quartic. And I'll just keep this one basic, x to the fourth. And then after that would just be the nth degree. So here's a couple more review. I'm going to save these for you to fill in. So examples 2 and 3 I'll leave for you so we can get into the new stuff, end behavior and graphing polynomial functions. So anytime you come across a function you don't really know how to graph, what you should do is just create an XY table, pick X values, plug them in, and then whatever you get out will be your Y value, plot those points. To keep it easy, I'm going to try to use the same 5, so we'll go -2, -1, 0, 1, and 2 for all of the rest of the examples, just to keep it the same. So if you wanted, you could go through, pause the video right now, fill all this in if you want. Didn't leave myself enough space there. Or you can just wait, I'm going to have to fill it in as well. So we're starting with f of x, here we go, linear function. My highest exponent is 1. And hopefully you guys all know what these look like. But if you plug in -2, you get -2 back out. If you plug -1 in there for x, you get -1 out. And then same thing with 0, 1, and 2. And probably to no one's surprise, when we graph this linear function, it is indeed a line. And it looks like that. Okay, and you probably know how to graph that using slope-intercept form, and that's great. The next example is very similar, except it's just -x. It is still a linear function. Spell that right. There we go. So now when you plug in -2, so you get -2, which just turns it into +2. You get +1, 0, -1, and -2. So here is what our graph of this linear function will look like. Very similar, just going the other way. Now let's talk about end behavior. So this is what our end behavior used to look like. We actually decided to change it. So here's how you would read it. So right over here, make a big old dot so everybody can see where I'm at. So as x approaches infinity, or you could say, and this is the word that we're going to use, as x increases, f of x here stands for our function. So what's happening to our function as the x values increase? Well, you can start anywhere on our graph. We'll start here. So as my x values get bigger, so 1, 2, 3, 4, 5, 6, what's happening to my function? It's going up. So we can also say that it is increasing. And as my x values get smaller, so we'll change that quick. As x decreases, that's what this is saying right here. Or you could say as x approaches -infinity, either way. What's happening to my x values? So as the x values get smaller, our line is going down. So we would say decreasing. Okay, over here, it's also a linear function, so we can say as x increases again and as x decreases. That's what these two variables and symbols are saying in words. F of x, again, stands for a function. What's happening to our function as the x values get bigger? This time, we're going down, so our function decreases, or is decreasing. As the x values decrease, or as they get smaller, my function is actually increasing. Fix that. Increasing and decreasing. So that's how we're going to look at these. All right. The next example we have is a quadratic, and we just got done graphing these. Wow. In one form in the last unit. But we still want to be able to graph these, any quadratic function, not just in vertex form. So we'll make our xy table with -2, -1, 0, 1, and 2. And like I said, I'm always just going to use these 5 just to keep it easy. Oops. So I don't have to think too much about what x values to pick. You can pick any x values you want, but like I said, we'll just keep it easy. So plugging these into the function, so we're going to take -2 squared, and we get 4. So if you plug -2 in and you square it, you end up with 4. We'll go ahead and do the same thing with -1. If you square -1, you get 1. If you square 0, you get 0. 1 squared is 1. 2 squared is 4. So we'll start from the origin. We'll plot that point -2, 4. We'll go back to the origin. We'll plot the point -1, 1. Then 0, 0, 1, 1, and 2, 4. So there's my parabola, as you might have expected. So now, as x is increasing, I'll put that over here. Again, probably the last time. And decreasing here. So as x is increasing, my function f of x is, as my x values get bigger, my function is also increasing. As my x values go to -infinity, or as the x values decrease, guess what? My function now is increasing. Okay, so we'll try another example over here. This time we're plugging values into -x squared. So negative and then -2 squared is how that would look. So you're squaring -2, which is 4. And then you still have this negative on the outside. So then we're going to take 4 and we're going to make it -4. 1 squared is 1, but then make it negative. So -1, 0, -1, and -4. Going to the origin, plotting the first point, -2, -4. Then -1, -1, 0, 0, 1, -1, 2, -4. So here's my parabola going the other direction. So now, as x is increasing, my function is decreasing. And as x is decreasing, the x values are decreasing, my function still is decreasing. Okay, moving on to cubics. The exact same thing here. So x and y will go -2, -1, 0, 1, 2. Get this one ready. Okay, so let's plug these in quickly. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So plotting these points now, -2, -8 is way down here. -1, -1 is there. 0, 0, 1, 1, and 2, 8. So my cubic function kind of looks something like that. As my x values are increasing, my function is increasing. That's what's happening at the end. Remember, this is all based on end behavior. As my x values decrease, my function is also decreasing. Okay, for a cubic but with a negative in front, it's going to be similar to the quadratic with a negative in front. We are going to cube the number and then flip the sign, basically. So -2 cubed is -8, but then this negative out front makes it +8. So -2, +8. Did I? 5, 6, 7, 8. Yeah. Okay, -1 cubed is -1, but then again, the negative out front makes it +1. 0, 0, still it doesn't change. 1 cubed is 1, but the negative now makes it -1. And 2 cubed is 8, but the negative will make it -8. So, if I just put a negative out front, it kind of just flipped it across the x-axis. And how does that affect my end behavior? So as my x values are increasing here, my function now is, or the end behavior is that it's going down, so it is decreasing. As my x values are decreasing, now my function is actually increasing. Okay? Yeah, last two graphing examples. We have quartic. So let's put that little note here, quartic. I'll set up my tables. The same 5 x values, just so it's a little less thinking. You can pick any x values you want, but I'll just pick a couple negative, couple positive, and of course 0. All right, so now we are taking these to the 4th power. So -2 to the 4th power. -2 times -2 times -2 times -2 is 16. Now, graphing is going to be just somewhere up here. We'll do our best. -1 to the 4th power is 1. 0 to the 4th power is 0. 1 to the 4th power is 1. And 2 to the 4th power is 16. So again, somewhere up here. So it kind of looks like a parabola a little bit. Yeah, in a way. In a way, it kind of looks like a parabola. So let's talk end behavior. It does change, though. If you pick different values, it will change a little bit. So as x is increasing, the end behavior is also increasing. As x is decreasing, guess what? The end behavior is still increasing. And you can probably make a prediction based off of what's going to happen here with the negative in front. So we're going to take these to the 4th power and then just change the sign. So -2 to the 4th is 16, but the negative makes it -16. So now that puts us somewhere down here. This is going to be -1. 0, 0 doesn't change. That's also going to be -1 and -16. So just kind of flipped it upside down again. And there it is. So as my x values increase, my function is decreasing. And as the x values decrease, my function is still decreasing. So let's talk about maybe a little quicker way to identify end behavior. So if your degree is even, meaning anything that'd be like x to the 2nd, x to the 4th, x to the 6th, and so on, as long as your a value is positive, so a is positive, that means that as your x values increase, your increase or decrease, sorry, your function will increase. So the best way I found to help me memorize this is just kind of knowing what an even function looks like, the end behavior. So both the fourth power, the quartics, and the quadratics, they both kind of look like, you know, U shapes. Now the fourth power changes a little bit as you start adding numbers behind those functions, but you get the general idea. So I would say if A is positive, the end behavior, here's just a general sketch. This is what it looks like. And like I said, there might be some more little kind of curves happening in between, but the end behavior is going to look the same if A is positive. If A is negative, all it's going to do is flip it upside down. So just a quick sketch of an even function where A is negative. It's going to look something like that. If you can remember that, then you know that your end behavior is decreasing in both directions. If your degree is odd, so something like x to the first, x to the third, x to the fifth, and so on. If A is positive, that's what that is right there. If A is a positive number, your graph is going to look something kind of like this. Now again, that could change. That's kind of like a cubic function. It could just be a line. It could have more bumps in the middle, but either way, it's going to kind of have that same general shape. If you can remember that, that'll help you with your end behavior. So as the x values increase, my function increases. As the x values decrease, my function decreases. And then, of course, if A is negative, that's what this is saying right here. All I need to do is kind of flip-flop it, so we'll kind of draw something like that. As my x values increase, now my function's going downhill. And as my x values decrease, my function is increasing. So, describe the end behavior. So we did all that just to get to this, so we don't actually have to spend all the time graphing, which we'll have to do a little bit of, but not as much as we just did. So, describe the end behavior. So first of all, identify your highest exponent. It is odd. I really don't care that it's a cubic in this example. I just care that it's odd. 3 is an odd number. So I know if I were to graph it, it's going to look, well, and I should probably write it in standard form first. So let's do that. So negative 2x cubed plus 3x squared plus 4x. Just good practice writing in standard form. The reason is, so now my highest exponent is 3, so yes, it's odd, but my A value here is negative. If I jump back up, I want degree odd, but a negative A value. So I know my graph is going to look something like this. So that'll help you with end behavior. So as x increases, that's this right here, my function is decreasing. As x decreases, my function is increasing. So if you remember kind of what those look like, it'll be a nice little shortcut for you. The next one, let's write this in standard form. F of x equals 2x to the fifth plus 7x squared minus 3. Okay, so my highest exponent is odd. Okay, so it's going to be one of these two examples over here. And my A value is positive. So I know it's going to look something kind of like this. I just need a quick sketch to understand the end behavior. So as my x values increase, my function is increasing. As my x values decrease, my function is decreasing. So I'll leave the last two up to you to finish up. Write them in standard form if they're not already. Identify even or odd, and then try to figure out over here. Is it going to be that sketch, that sketch, that sketch, or that one? Figure out which one, and then try to identify the end behavior from there.